Over to you, Amir. The virtual stage is all yours.
Yeah, thank you very much. And hello, everyone, and welcome to this session. My name is Amir Meimand. I'm Principal Solution Engineer in the area of data science. And during this session, we are going to talk and practice about how to build a predictive model which is explainable and enable business user to understand the underlying reason for the prediction and make a better decision. And also, if we have time, we will go through like how we can deploy this sort of model on the cloud and make it available to everyone. So saying that, let me share my screen and then we can start. Um, okay. Apparently, I cannot share my screen. Can you please enable like screen sharing for me?
Yeah, wait, I'll check. I'll check. Just a minute.
Yeah.
Can you check if you can share it now?
Yeah, I can share it now. Thank you very much. And can you please confirm if you can see my screen, if my screen is visible?
Yeah, yeah, it's visible to me.
Okay, great. So before we start, a few housekeeping items. So this will be like a hands-on session in which I just build a model in the real time for you by writing code and will explain all of the steps. All the content of this session, including like the data set, the code, and the deployed model, everything is available on my GitHub page, and this page is available to you. So during the session, you don't need to take any notes or you don't need to write code with me because all the content will be available to you. And I'm going to paste like this link to my GitHub page on the chat box. So if anyone wants to just download it or have access to that, everything is available here. And the last thing is the fact that this is like hands-on session, so we are going to write code in the real time, train the model and deploy the model. So there will be no slide, so everything will be like hands-on. Okay, so saying that, let's get into the session and first articulate like the business problem that we want to solve, and then start writing code and building model for that. So from the business perspective, you can assume that I'm business owner. I'm a restaurant owner that run a multiple restaurants across the country. And I come to you as a data scientist and ask you what is like the predicted profitability of my restaurants for the next year. So this is the first business question that I have. And the second business question, which is like quite more important, is that how I can improve like the profitability of my current restaurant. So as a business, as a data scientist, you need to build a predictive model that can predict the profitability of my restaurants. And also you need to build a secondary model that can tell me how what option do I have to improve the profitability of my restaurant. So to build this predictive model, we have a training data set. It is available in the GitHub page as well, which has like the historical data of like some restaurants in the past. So in this data set, each row represent the information of like one restaurant. So we have like some information or characteristics such as like the age of restaurants. Is it like developed restaurants or well-known restaurants or recently opened restaurants? What type of restaurants we have? Is it a cafeteria or is it like full service restaurants? What is the price range? What is the capacity of the restaurants? Which area this restaurant is located? What are like the total number of items in the menu? Some of the restaurants only serve salad, some of them serve like salad and sandwich, and some of them are like more item in the menu. And last but not least, we have like the historical like profitability of this restaurant. So basically, we are going to build a predictive model that predict like this last column, the profit, based off like other characteristics of restaurants. So it would be like a regression model because the target variable is continuous. Another point about this session is that since the main focus of this session is on model building and model deployment, we are not going to spend any time on like data exploration. So this data set already is clean. So we can just start building model off of that. One quick observation by looking at this data set is the fact that all of my like predictors or all of my features um, are categorical, so I do not have like any numerical value here. So during the model building process, I need to apply like some pre-processing, especially one-hot coding, to convert all of this categorical variable to the numerical value, which is like consumable for my machine learning model. Now, saying that, let me jump into my Jupyter notebook and start building model by importing first some libraries and then doing some data processing and then building the model. So in the first step, we are just importing some standard library. We are using like NumPy and Pandas for like data manipulation. And then for model building, we are using like the sklearn, which is like a very popular and very standard like machine learning library to do like a variety of like pre-processing, such as like one-hot coding, standard scaling, and also building like pipeline and then building like some models such as like random forest, lasso regression, k-nearest neighbor, and so on. So and in the second step, we obviously need to read the data and build the model. But prior to that step, I want to create like a helper function, which enable me to select my model. So this let me run this code. So I'm defining like a function here, which I call it like regression selection. So this function basically get like three main values. The X is your is the features of your training data, Y is your target variable, and matrix is an option. So basically, this function gets your training data set and iterate over like multiple model, like random forest, k-nearest neighbor, and lasso regression. And for each of these model, it go through like different set of parameters. So each of these model has like different set of parameters. Like random forest has like n estimator, max depth, and mean number of sample split. And for each of them, I define a range. So this function go through like all of this like algorithm and build your model for each of these set, and then it will select like the best model, the model that give you like the best R square. And this R square is adjustable. If you want to select your model based off like a different matrix, you can just change it. Like for example, if you want to look at like the total error or the absolute error, you can just change this R square to whatever you want, and then ultimately it just report the best model for you. It is a very generic function, so you can use it for like any type of like data that you have, and also you can add like more algorithm to it if you want. So it is pretty much like a generic type of code that you can use for any type of data. So the next step is reading the data. So I read the data from like the CSV file that I have. Like this is like my training data set. And then I need to specify my target variable. In this case, my target variable is profit, because profit is like the variable that I want to predict. And then I need to define like two set of like a variable, like the categorical feature and numerical feature, because for each of them we need to apply like a different set of pre-processing. In this specific use case, all of my features are happen to be categorical, so I just put the name of all of my features here, and the numerical feature are none or null. But if you have like a different data set in which you have like the combination of like categorical variable and numerical variable, you can just put the name of numerical variable in this list as well. So I'm defining like this, and then the next step is basically applying some data pre-processing. So as I mentioned earlier, we need to convert all of these like categorical variable into like numerical value by applying like one-hot coding. And even in the case of like having numerical feature, sometimes you need to apply some pre-processing to your numerical feature to scale them down to make sure that your model is balanced. So to do that, we are going to take advantage of like creating a pipeline in sklearn. So basically, sklearn enable you to create a pipeline which like apply like different set of like pre-processing sequentially into your data set. So the first line of code create like a pipeline for my numerical value. So if I have like any numerical feature in my data set, it basically apply like two pre-processing. It first like apply like a imputer. So if there's any null value, it automatically replace it with like the medium value of like this field, and then it apply like a standard scaler to adjust the range of all of my numerical variable into the same range. So in this case, since we don't have any numerical feature, this part is irrelevant, but you can keep it into your code in the case that you want to apply this code to a different data set with some numerical value. And then for categorical variable, we apply like a one-hot encoder. So it basically convert each column with like a categorical variable into the matrix of like 0, 1. So each of your categorical variable will be automatically replaced by the vector of 0, 1. So we first define like these two like preprocessor, and then define like one unified pipeline, which I call it like encoder, and then it apply like both of these like transformer, like numerical transformer and categorical transformer to the original data that I have. So by basically by applying like this code, um, um, I just convert all of my data into the format that is consumable um, for my machine learning model. And here, sklearn generate like a very like nice chart for you that you can visually see like what type of like transformation or procedure apply to your data. So as we said, for numerical value, it first impute the value and then apply like a standard scaler. And for categorical variable, it apply like one hot coder and then give you like one data set. I see a question in Q&A. Please provide your Jupyter notebook for us. So the Jupyter notebook, along with like all of the code, is available on my GitHub page, and I paste the code, I paste the link into the chat box. So you have like access to the Jupyter notebook through like modeling. So this is like the Jupyter notebook that I'm using. So it is available on the GitHub page. Okay, so till that point, we basically apply some pre-processing to the original data to make them available and consumable for the machine learning model. Now, the next step is basically building our model or selecting our model. So to do that, I'm going to run this part of code. So it basically call my helper function. Look, regression selection is the function that I defined previously. And to improve the performance, I'm just going to reduce the range of parameters here, because if I want to run it for the whole range, it would be like very time consuming during the session. So I'm going to just reduce this to save some time. But nevertheless, by applying this part of code, I'm basically sending this training data. X is basically my my training like features, which is available in the form of like a transformed version, and label is basically my target variable, which is profit. I send them into the regression selection, and then regression selection iterate over like different type of model, like random forest, k-nearest neighbor, lasso regression, and train each of these basically train each of this model based off like different set of parameters, and then ultimately it select like the best model that give me like the best R square. So we are using the R square as a as a model selection criteria, but you can use like any other matrix. So it is just it is a default in this function, but you can change it. So since the data set is quite large, it takes some time for the code to run and select the best model. So I'm going to give it like 1 or 2 minutes to finish the model training. And in the meantime, if you have any question, please feel free to type it in the chat. So I saw a couple of questions asking for the link to the GitHub repository. I just sent the link into the chat box, so you have access to the GitHub repository, and then again in the GitHub repository you have access to like everything. This restaurant's profitability training is like the set of data that we are going to use for training the model. Modeling is the Jupyter notebook, and then the rest of the files are required to deploy the model. So yeah, so there is a second question asking, can you please go over the helper function again? Yeah, sure. So this helper function is basically some type of like model selection. So you send your training data into the helper function, like regression selection. X is the set of features that you are going to use to train your model, and Y is your target variable. And then the function basically iterate over different type of model and then train each model individually. Like for example, it trained like random forest with like this set of parameters, like when the n estimator is 100 and then the max depth is 5 and then the minimum number of sample is like 4, and then it trained like another random forest with like different set of parameters. So it basically training like multiple random forests for you. Very similarly, it trained like multiple k nearest neighbor for you, and it trained like multiple loss regression for you. And then at the end, it just compare all of this model together to see which one give you like a better R square as an indication of like your model accuracy. And then it will select the model that give you like the best R square. And we are using like a k folding of 5, so it automatically like split your data into train and test, and then do everything automatically for you, and then finally it just return back like the model that give you like the best set of accuracy. Does it answer your question? Or if there's any other question about the helper function? The What is the R square? Yes, the R square is an indication of like accuracy. There are like many different statistical metrics that you can use to measure the accuracy of your model. For the regression model, basically when your target variable is continuous, R square is usually like one of the best metrics that you can use. So yes, it is correspond to the accuracy of your model. But again, sklearn like support some other matrix, and you can use them too. There is another question about can I cite or use your script for another modeling project? Yes, you can use like this script is written in a very like generic format, so you can use it for any other data set. So the only thing that you need to do is just specifying your set of data, specifying the name of column, your target variable, and then the set of variable, and then you can just use like the same data. Where can we test our models? So basically this helper function automatically train and test your model. So for example, here this part of code is done. So it means that helper function build all of this model, train them and test them, and then return back like the best model with the highest like accuracy. So if I type like CLF, which is the output of a helper function, I can see which model is selected. So apparently random forest with like this set of parameters like n estimator 200, mean sample split 4, and max depth of 15 is selected as the best model for the accuracy. Okay, I'm going to answer one last question and then we keep going. How to select which stats should we go with for testing the accuracy? So it really depends on the business problem that you have. But as I said, when you are dealing with regression model or continuous variable prediction, R square is one of the best criteria that you can use. Okay, so I will answer the rest of the question later. So till that point, we just select like the best model, and then the next step is just training this model, because we just select this model based off like the part of our data set. So this line of code is going to like train this random forest based off like the whole data that I have. So by running this part of code, we pre-process the data, we select like the best set of data that we had, and then we train the model. So now our model is built, and we can use it to get back the result of prediction. So basically, to get back the result of prediction, I can say like model predict, and then for example df like head one for the first row of my data. But if I run this part of code, you may see that it returned an error for me, and it said that could not convert a string to float. So the reason is the data that I used to get back the result of prediction, aka df head one, which is like the first row of my data, has like the original data. So it has like a developed or cafeteria. So these are like the categorical value, which my model cannot understand because I already convert them into the numerical format. So to get back the result of prediction, I need to apply the same transformer to convert the data to the way that my model can understand. So to do that, I'm going to create a second um, a pipeline, and I call it like prediction. So basically, this prediction first apply like encoder, the same type of transformer to the data that I send, and then convert them in a way that model can understand, and then send it back to the model. So the model can return back the result of prediction. Now, instead of like running model, let's run the prediction to get back the result of prediction. So now you can see that the model, we send like this row of data into prediction. Prediction first apply encoder, convert it to the format that model can understand, and then apply my predictive model to that. And then the model return back this number, which is like the predicted profitability. So till this point, we basically build a model, train a model, and then create like a pipeline that can get back the result of prediction for any type of data that I have. So now the main challenge here is that I can use this model in my Jupyter notebook, but if I close this Jupyter notebook, then this model will be gone. So I want to save this model somewhere and being able to use it like in the future without like necessarily retrain my model. So to do that, we are going to use like a library which is called like DIL. So DIL library basically enable you to save like any object or any trained model. So it basically serialize your model, and then you can just use this model later. So to do that, we just need to specify like the name of the model. In this case, I'm going to assign a name to it like profitability prediction, and then I just create a file for it. So by running this part of code, if I'm going to my computer, you see like this file is generated, a profitability prediction. So this is, I basically save my model in my local machine, and then moving forward, I can, if I want to get back the result of prediction, I just need to load this file and then get back the result of prediction. So we save the model, we train the model, we save the model. Now the next step is just creating an app to make this model available to the business user. So so assuming that you build this model, but for a business user who is not familiar with like Jupyter Notebook or Python, it is not possible to use this model because they cannot just write like this line of code or any line of code to get back the result of prediction. So we need to build a very user-friendly app that enable like a business user, someone without like any statistical or machine learning knowledge to use this model. So to build the app, I'm going to use like a Streamlit. So I'm not sure if you are familiar with Streamlit, but basically a Streamlit is a very user-friendly like Python package which enable you to create a user interface for your Python code, and then even enable your business user to interact with this model in the real time. So you can install a Streamlit very similar to like any Python package that you have. So now let me show you the code of like my Streamlit that I create. So basically in my second code, I need to import like the same set of library that I used to train my model. And then this part of code, it basically load my saved model. So if you remember, we trained the model and then we save it under the name profitability-prediction.save. Now I use like the load method to load this method. So basically, to get back the result of prediction, I do not need to retrain my model. I only need to load this single file and then get back the result of prediction. So we load this model under the name model. The rest of the code is basically creating like an interface, like putting a title or subtitle, and then we are defining some input box to enable user to give us like the characteristics of their restaurants, like the area is in downtown or suburb, what is the age of restaurants, and then after getting this input variable, the user can click on this bottom, generate insight, and then we are running this model. So we basically model.predict basically return back the result of prediction. So this file basically generate a web app for you to create this interface for you. And the question is the Streamlit code on the GitHub as well? Yes, it is on the GitHub as well. So app.py is basically the code for the Streamlit. So now let's run this code to see what type of like interface we are getting. So when you are using a Streamlit, you cannot run your Python code from the IDE. You need to run it by a Streamlit command. So if I go to my a terminal and run app1.py, so it basically run my code and kick off my app. So it may take like few seconds for Streamlit to just get the data and run the app. So let's give it like a few seconds and then it will come. All right. Okay, so as you see, Streamlit run the app in my local machine. This is like the local host .8505 is my app, and it automatically kick off the app, so it is available on my browser. So it is currently running the app. For the first time that you run the app, it may take some times because it need to like load your model and then create an interface. But after the first time, it should be like more straightforward and faster. And also it depends on your browser. So if you use like Chrome, it should be faster. I'm currently using like Firefox, so it is a little bit like slower than other browser. But yeah, we can wait till it's come up. Okay. So it is coming, and when the app loaded completely, I will go through the code to show you like which part of code is doing what. So this is like our web app that is available. So if I minimize this window a little bit, I can just show you like which part of code doing what. So okay. All right, let me use like the Chrome because Chrome is like more user friendly. Okay, so you see like this part of code, like restaurants profitability, how to improve the annual profitability of your restaurants. These are basically correspond to like this part of code in which I define like title, subtitle, writing something, and like defining like again subtitle. And then in the and then I have like some parameters here, so the user can select like the characteristics of their restaurants. So this is like correspond to this part in which we define some input box to enable user to tell me like in which area their restaurant is located, what is the age of restaurants, and so on. So I can just select like the characteristics of my restaurant. Let's say I have restaurant in suburb. It is very well-known restaurant. It is like full service. The price range is like $2. There is like less than 10 seat, and then I'm serving like less than 5 items. So these are like the characteristics of my restaurants. And when I click on generate insight, the code basically run my loaded model. So model.predict X will get this data from interface and return back the result of prediction. So if I click on generate insight, it will give me like the profitability. So the profitability of restaurants with these characteristics is like 81.39 K dollar per year. And you can just change it to like a different like thing, and every time you change these parameters, it will give you back like the updated result of prediction. So this is the app that we can build, and anyone can interact with it. So you can imagine that as a business user who does not have any knowledge of like machine learning or data science, they can easily like interact with this app and get the result that that they want. So saying that, let me kill this one, and we have only like additional like 20 minutes. So I want to go through like the rest of the presentation with you. So till now, we built like a predictive model, which basically give us like the result of prediction. However, the business question that we had was how we can improve the profitability of these restaurants as well. So to answer to this question, we need to build an explainable model at top of this model. So if you are not familiar with like explainable AI is a method that enable you to understand the importance of each feature for every single prediction. So you can easily realize that which feature has like positive or negative impact on the result of prediction. And from like the theoretical perspective, there are like many method of explanation. The two like very popular and famous method are SHAP method and LIME method. And there are like many library that implement like this method out of the box for you. I don't have plan to go to detail of like the theory behind this method, but there are like many articles in the web. So if you search for like a SHAP method or LIME method, you can find them. The Python library that I'm going to use in this in this session is like OmniAXI. So OmniAXI is a very user-friendly package that is able to explain any type of machine learning model for you, and it generates like a variety of explanations. So you can find like a ton of value on information on their GitHub, and it is like model agnostic, so it can explain like any type of machine learning model, even natural language processing or image processing. But in this case, I'm going to use it for the purpose of like explaining the model that we built. And the most important point about like OmniAXI is that it is very user friendly. So it is really like low code library to get back the result of prediction for like any type of model that you have. So to use to build like the explainable AI, I'm going to import like the OmniAXI library, and so we are going to use like the tabular module and also the explainable module. So the thing about like the OmniAXI is that it only consumes the value in the tabular format. So you may need to convert your input data into tabular format, which is like understandable for OmniAXI. And the next step is just creating like an explanation for our model. So let me paste the code here and then walk through like what does it mean. Let me see if it okay. So this part of code, it basically we are creating an explainer. So we are telling OmniAXI what type of explanation we want to generate. So we want to generate both LIME and SHAP. The model that we have, the type of model is regression. If you have like a classification, you can change it to classification. And then what is the data? So we are going to use like the training data set to build like the explanation. So we are using like the same data that we use to train the model. The only thing is that we need to use like tabular module to convert this data in a way that OmniAXI can understand. And it is very easy. You can just use tabular module, specify the data, and also you need to specify your categorical column, which we already did. And then specify the model. The model in this case is the prediction, which get like the input and then convert it to the output. And then you need to specify the parameters. I just use like the default of parameters, so it's not a big deal. The most important point here is about like the pre-processing. So we need to define like a pre-processing for OmniAXI, which convert like the input data into the way that is consumable for my machine learning model. So as I said, OmniAXI by default use data in the format that it can understand, which is like a tabular format. So I need to define a helper function here. I call it like pre-process, and it easily convert, like get the data and then convert this tabular data to pandas data frame. So most of the machine learning model using the pandas data frame as an input. So you can always use this pre-processing to pass your data to OmniAXI, and then it will generate the explanation for you. Now this model is built like explainer is built, and now I can just get back the result of like explanation for any row of data that that I want. So let's go through like a very quick like example here to see like how this explanation is basically works. So I can apply like this explainer. So if I type like explainer dot explain, and then I just change it to let's say to tabular dot um, I'm not sure if this work, but you know what? Let's test it on the app, because that would be easier. So we create this explainer, and then very similar to the previous use case, we need to save this model, so we would be able to use it in the app. So I'm going to just use the same method to create like this explainer file. So by running this part of code, it just generates like this file for me, explainer. So now in my new app, I can use like this explainer to get back the result of prediction. Now let me show you like the final version of app that we have. So this is like the final version of app. It is very similar to the previous version. So the only difference is that in this case we are just loading like both model, the prediction and the explanation. So I have like model and explainer. I get the input data from the user, and then in addition to running the prediction to get back basically the result of prediction. So this line of code give you the prediction, and then this line of code give you like the explanation. So I get the explanation for these individual restaurants that users select, and then it will generate a chart which show me like which variable has positive or negative impact, and then it exposes it into UI. So now let's run the second app that we have, which is like more advanced, and it is like app.py. So let's run this app, and it give us like a better better insight about the model. Let's give it like a few seconds to load, and then we can just see how it works. And in the meantime, if you have any question, please feel free to write it in the chat. Okay, so the app is loading. Again, for the very first time that you run your app, it takes some time because it loads the data. Yeah, we are using like save files to basically load the model, because we don't want to like retrain or model everything every time that that we run the app, because it would be like very time consuming. So you ask about my LinkedIn profile. Yeah, I will paste my LinkedIn profile in chat. Can we run explainable at Python editor? Yes, you can run explainer at Python editor. So basically, if you look at like the app file, this part of code is basically you can run this part of code in your Python editor to get like the explanation. I didn't run it in the Python editor only to save time, but yeah, you can just run it at any Python editor that you have. All right, so this is our new app. The the interface is very similar to the previous one, but it give us like more insight. Let's say let me show you it in Chrome because it's more user friendly. So let's say we select like some characteristics for a restaurants, the price range less than 10, and we are serving like only 5 food, and then we can even select like what type of method we want to use to generate the value. So by default, we are using SHAP. When I click on generate insight, this time my app run two model, the prediction and the explanation. So it first gives me like the predicted profitability, which is 81 K dollar per year. And also it generates this chart, which tell me that what is the contribution of each of these factors. Like for example, I can easily see that price range is something that negatively impact the profitability of my restaurants, or the number of item in the menu, the area, and also the capacity. So I can try like a different scenario here. Let's see what happens if I increase the capacity of my restaurants. And then by generating insight, um, I can realize how I can just improve like the profitability of my restaurant. So by increasing the capacity, you see that the profitability increased significantly, and the model tell me that in this case I also need to increase the price range as well. So this is very like a user friendly way that even the business user, without having like any data science or machine learning knowledge, can get back the result of prediction and also understand the contribution of each factor, and ultimately come up with a scenario that can basically come up with a scenario that potentially can improve the profitability of restaurant. So we only have 10 minutes. I'm going to answer one or two more questions because I want to spend like probably 5 or 6 minutes to show you how you can deploy this app on the cloud, because that part is quite important. Um, uh, can we use the Apache PySpark to deploy this model? Yes, you can use like any other platform. The second question, is there any alternative library other than OmniAXI which can be used for explainability? Yes, there are like a bunch of library, like SHAP by itself has a library, Lime has a library, and there are like some other library. As I said, I use OmniAXI because it is like a low code library, and it generates all the explanations for you like automatically. The next question, how did we select this feature very initially, price range? Is it based on the business domain? Yes, we select this feature by going through like some feature engineering and also business domain knowledge. I did not go through like the data exploration phase because our time was limited, and the main focus of this session was on model building and model deployment. But ultimately, yes, it is like the combination of like feature engineering and also business domain knowledge that help you to select these features. So let's spend like 5 minutes to deploy this model. So this model currently exists in my laptop. And as far as this model is in my laptop, it doesn't do any good for anyone because no one have access to this model. So to make this model available to everyone, we need to deploy it on the cloud so everyone can use it. Um, mm, and to do that, we can use like different like cloud platform. We can use like AWS, Azure, or Google cloud platform. In this case, I'm going to use Heroku because Heroku is very like easy to use, and it is like it do most of the thing like automatically for you. So you can create an account in Heroku for yourself for free, and then you can just deploy like a light app that you have automatically there. So the only thing about to deploy your model in Heroku is that you need to have like all of your code and saved model in your GitHub, because Heroku can connect to GitHub. So I'm going to use my own GitHub to deploy the model on Heroku. We don't have like to have like the original Python code. Basically, what you need to have is only this saved model. So all you need to have is like this profitability prediction save and explainer save. But I just put like the data set and Python code that other people can use, but you don't have to have them for the deployment purpose. In addition to your saved model, you need to have like this requirement file, which basically tell Heroku what library you need, because Heroku need to know what library to install on your server. So I specify like NumPy, Pandas, Streamlit, Sklearn, OmniAXI, and Deal. So these are the library that I have. And the second file that you need to have is like this setup file. So the context of this setup file is very standard. It basically echo the Streamlit and then make your environment ready. So if you want to deploy your any app on the Heroku, you can use like this code. It is like very straightforward. And then ultimately we create like this file, proc file, which basically tell Heroku what to run. So after your environment gets ready, Heroku first run your setup file and then running your Streamlit app. So this is like the same command line that I run in my terminal. So you need to tell Heroku like what command line run on your environment. So I'm going here, create a new app. I assign a name to it. I call it like Insight Test. The name is available, create an app. And then we are going to connect it to the GitHub. So for the first time, Heroku asks you to log into your GitHub. So I already did that. I specified the repository name, which is like DataHour, search for that. And then I'm connecting to this. And when I'm connecting to that, I can just deploy the branch manually. So by clicking on that, Heroku start like deploying my app. And then if I go to activity, you can basically see like all the log file, what is going on. So Heroku is going to install like Python. It read like the requirements. So it is installing all the library that I need, and then ultimately deploy my app and make it ready. So it takes like 3 to 4 minutes for the app to deploy it and get up and run. In the meantime, if you have any question, please feel free to put it on the chat. So someone said the Heroku stopped their free service from December. Yes, that's free. Their app deployment is not free anymore, but the cost to deploy like the app is still very minimum. I think it is like as less as like $7 per month. So if you want to run like a light app, Heroku is still like a better option than AWS and Azure cost-wise. But if you are going to deploy like a heavy app that need like a heavy computation, then in this case like AWS and Azure or Google GCP might be a better option. There's another question: what is the difference between Streamlit and Flask? Basically, the main difference is that Flask basically deploy your model and create like an API for it. So Streamlit is more flexible in a way that you can build and design your user interface. So Streamlit is better to design an app with like better user experience, as Flask has like some limitation in designing the UI, but it might be more efficient and faster to run your model. So there is like pros and cons for each of them. If there is any other question, please feel free to ask. I think it still take like another 2 minutes for Heroku to set up the app. Again, all the code is available on my GitHub page. If you happen to want to just deploy this model on Heroku for yourself, you need to fork this repository on your own GitHub account, because when you are launching app in Heroku, you need to log into your own account. Do we have to follow ML ops for deploying models every time? Can you elaborate on follow ML ops? Do you mean that if you retrain your model, or if you elaborate on question, I can answer it better. Yeah, so someone said my app on AWS is costing me $10 per month. Yeah, as I said, if it is like a light app, Heroku is cheaper. So okay, so the app is already done, so you can see like in this box that the model deployment is finished. So I can just open the app. So this is the link to my app, so I can just send this link to anyone, and I can just basically share my app with like rest of the world, which is a very great thing. So anyone can just run this run this app and have access to that, and you don't need to have like any Python or any environment. Everything is taken care of in Heroku. So we can just select the information of our restaurants, and we can just generate insight. It run like the same model, give me like the predicted profitability, give me the explanation, and everyone can interact with it. If you are interested, I'm going to send like the link to the app here. This app will be up and run for like next hour. So if you want to just open this link and interact with it, feel free to do that. And yeah, all the code and everything is also available on my GitHub repository if you want to just regenerate this model for yourself or apply to like any to any other data set. So we have like another like 4 minutes. Feel free to ask any question that you have. The question is, how about option for real-time deploy? So yes,
Yeah, I'm sorry to interrupt, but just launch
sorry, your voice get disconnected. So I'm not sure if just only for me or for everyone.
am I audible now? Hello.
Yeah, I think we can hear you now. Um, uh, not anymore. Eh,
Okay. So I'll just launch a feedback poll and then we'll move to the outro. Okay.
So in the meantime, someone asked about like the real-time deployment. So when you are connecting your so if for Heroku, when you are connecting your GitHub to the app, there is an option for like deploy from GitHub. So every time you make a change on your GitHub, Heroku automatically like redeploy this new model for you. But yeah. Okay, so I guess we are run out of time. There's time for feedback. So thank you very much for joining this session. Yeah, I'm going to put my email address into the chat box. So if you have like any further question, please feel free to send me an email. I'm also very active on the GitHub on the LinkedIn. So if you want, please like feel free to just connect with me on the LinkedIn and also on the GitHub. I believe I shared the link to the Heroku app. So I'm going to paste it again on the chat box. Okay.
Yeah, thanks. Thanks a lot, Amir. On the behalf of Analytics Vidya, I would like to thank you for your time and for delivering such an excellent session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in future. We have a few requests in the chat as well, that we can have another session for model deployment. So yeah, we can have more such sessions as well. I hope you guys have filled the feedback poll. If not, I request you to please fill in the poll about the feedback, as it helps us to conduct more such sessions. If you wish to conduct a webinar at datahour.analyticswither. Just a minute. Yeah. The recording of this session will be available within 2 hours on the YouTube channel in the chat. But yeah, I'll put YouTube link. We'll be back with another session of data on like tomorrow, 13th of January. So here are the list of upcoming data session. Yeah. So here are the upcoming data sessions. So you can copy it. We'll end the session here. Thank you. Thank you very much, Amir, for your time. And
Yeah, of course, my pleasure. Thank you very much for hosting that.